Hello, everyone. Welcome to ITS 372. Okay, so video is recording, audio checks out. Okay, so let's get started. You should be seeing my slides here. All right, so here we are. So this week, it's kind of like we're officially getting started with, Unix in particular and system administration as well. So today, we will talk about two topics. Really, today is Monday, right, of our sysadmin class. So we will talk about what you see in front of you, the slides. These are from your book, so we'll just really go over the difference between workstations, servers, and services. Okay, so we'll kind of look at, so these slides that you're seeing here actually have three individual sets, and one is about workstation, one is about servers, one is about services. This week's lab will relate to services in a way. All right, so we'll talk a little bit about some of the terminology there associated with services. So I'll start actually with these slides today. And then after that, we're going to start more formally with our discussion of Unix, right? So we're going to call the lecture the Unix way. Okay, so we're going to call it the Unix way. Kind of like a philosophy, if you will, of Unix, and which is the underlying, it's one of the underlying philosophies of it. Okay, so the Unix way. So we'll start with workstations. We'll start with workstation server, these slides basically, and then after that we're gonna lead into the other topic. And then on Wednesday, our lab will be mainly about services, of course. Some of the commands in Linux for that, starting services, Apache, all that, and then we'll go from there. So the idea today, as I said, is to kind of lay out the difference between these three things, right? So we have services, we have workstations, which are your common PC. So if you think of a computer in your, in an office, right, that is used by a worker, an employee in the office, that's the workstation, right? So it's going to be some computer that we're all familiar with, kind of the PCs that you had growing up, or it's going to be a laptop of some kind. And system administrators are responsible for these computers. They're responsible for purchasing the computer from a provider like Dell, let's say. They get the computer, then they have to configure accounts in accordance with the policies of the organization. We'll see about account management in particular with relation to Linux in some upcoming lectures and labs. And then after configuring the machine, the machine has basically a life cycle of, it comes from initial, in life we have this thing called entropy, right? That it just kind of happens to everything. Everything has a tendency to go from organized to disorganized, right? So the computer will go from a state of stability to a state of less stability with time. And so the administrator has to manage that, okay? And, so there's a life cycle associated with it. We'll take a look at that. I mean, these are all intuitive things that, you guys already know about, but, that very much things you have to do. Set up the computer, obviously, set up the operating system, you know, whatever you're going to install, and then configure the programs that are available, configure all the security required, you know, firewalls, antivirus scanners, etc. And then after that, you know, give it to the employee. Then the employee, you know, runs the updates basically over time. That's some kind of an automated process. Okay, and then that's really, you know, the idea with Workstation. So we'll just look at that. Servers then come in. Servers are more like the, you know, the equipment, right? That is a more dedicated equipment. A company could either have the data center in the company itself. Usually they'll have like a small intranet in the organization for certain tasks. And then nowadays is very popular to have a lot of things in the cloud. So obviously a lot of servers, you know, AWS, you know, GoDaddy, etc. So then they'll need to remotely access those servers for, you know, if they're programming their applications, for instance, you know, some kind of e-commerce type of a presence, or some kind of a social media type of a presence, etc. So a lot of that, you know, just relates to the servers, that kind of hardware that supports, you know, the tasks that the organization needs to do. And then obviously that leads us, since we talk about servers, we're going to talk about services, right? And services will be the programs that are there functioning, and the services basically are the applications. They're running, they're doing something, some task basically, right? The programs themselves, which is really what the reason why the company has the servers is to provide the services. So that's kind of what this set of slides is about. I strongly recommend, as I said, either follow along in the book or just look at these slides, but you know, which summarizes the topic. And then after that, once we finish that, as we finish talking about services in general, we'll start then getting into the Unix way, right? The Unix way, you know, the overarching philosophy of the Unix way. And then from there, obviously, in the lab on Wednesday, we'll start looking at services. This is, so I'm being asked which of the two books. This one, these slides come from the sysadmin book, the one that doesn't really have anything technical. It's just more like recommendation, best practices. I forget the name. I don't have it in front of me, but it's something like practical. You can look in the syllabus, the practical one. And then all of this, the Unix way is coming from the other one, the actual Linux book that we have, sysadmin in Linux. Yeah. So as I said, you know, I went over every single chapter in the admin book, and I have these slides. Okay, so you can basically, I think the slides are enough, to be honest, because I put in a lot of text, so you didn't really have to read the book. So sort of summarized in there. But yeah, and then as I said, the Unix, pretty much everything that I do in Linux, right, in this course comes from that book, which that's really an excellent book. And I think I remember I said at the beginning of the semester, I cannot cover, I mean, that book is thick. The pages are really thin, and it's a dense book. So certainly, you know, I would recommend buy the Unix book, and because, like, you know, you'll probably want to continue learning more about Unix, and that's definitely the resource to get. And certainly, although you can find a lot of things online about Unix, it's not that well organized, I would say. So certainly that book will provide a very, very good reference. And if you work with Unix, you'll be using it for a very long time. All right, anyway, so that's kind of the motivation today. You know, we're starting sysadmin, obviously, with our computers, workstations, servers, services. All right, so let's start there. I won't go over every single slide. I will kind of just point out things. I already said, you know, pretty much a lot of the things written here. But, you know, a formal definition, of course, is in order. So a workstation is a computer hardware. Remember, that's what we mean computer hardware dedicated to a single customer's work. Either, pretty straightforward, a desktop or a laptop. Okay. Managing lots of desktops. That is one of the main tasks if you work as sysadmin. If that's your interest, certainly that will be your life. Part of your life, right? Is just getting computers, ordering computers, dealing with the hardware. Actually, it's like almost like a mechanical thing, right? Where things break down, have to change parts. Servers is the same. So the tasks will be, loading the system, the applications, updating the software, and configuring network parameters, the security of it. So now, again, even here, the solution is automation, right? So remember that you're not going to physically install the software, and on the operating system on the computer manually for every single one, right? So instead, you're going to use some kind of ghosting software, right? And ghosting software is, as the name implies, you configure something in the BIOS of all your computers to connect to some kind of a server. And then from there, you ghost, right? So that's the terminology. You ghost something or you image. You create the image that you're going to be loading onto all your computers. Okay, so that's pretty straightforward stuff, actually. So those are mostly GUI programs. You set up the initial computer that you want, you ghost it, and then you can push that out to your entire network. So that's kind of the approach there. Obviously, here's a picture, of desktops. So the idea is, you have some kind of a data center. This is a classroom. Got a printer over there, and then you got a photocopier machine, I think, is that? I don't know what that is. No, that's probably just a table. And then you have monitors, computers, CPUs are probably, well, you can see them actually. They're underneath the table. So that's what this means. So it's managing these computers. Oops, sorry. Okay, there, as I said, one of the things I said, there's some models of a life cycle, right? So you get the machine new, it's a build, it's clean, it's initialized, gets configured, but then over time, entropy, right? Entropy. So the tendency of everything to get out of order, right? And so the computer will start to fail, will start to have problems, you want to debug, so you have to rebuild, re-image, whatever you want to do. And eventually the hardware, as you know, especially in today's model, the hardware is changing constantly. So we got to replace the computers with new ones. So, pretty easy, straightforward things. But because this class is system administration and management, remember, it's not just about teaching you the Linux commands. It also has this goal of, because it ties in so well, right? Everything ties in so well with the Linux commands. We can also look at the generic point of view of just managing, or of the task of sysadmin, or some of the task anyway, not all of them, mainly as it relates to Unix. All right, so there's a machine life cycle. You can read through it, but it basically describes this graph over here. I already talked about this, so I'm just gonna mention the titles really. So initial OS and app installation. Remember, the key thing is automation, called ghosting, cloning, ghosting, disk imaging, and there's a lot of software programs for that. And obviously that's definitely the way to go, right? So if you ever work in a sysadmin, you will literally spend your time doing this because that'll save you a lot of effort in the future. Plus, you want to have all machines at the initial state and in a consistent state. You don't want machines, if you did it manually, you'd have all kinds of discrepancies. You want everything to be similar. You can see some tools there. This is the same. It just talks about, you build your own installation versus installing something that the vendor gives you. Remember, there's always going to be annoying things from the vendor there that you don't want to have. And then updating, those are things that you know about. That's essential for security. Updates, that's part of life when you have computers, right? So it's just essential. You know the difference between updates and so as I said, you can read through these. They're pretty straightforward. And then the network configuration, obviously you'll have to add the computer to the network, set up accounts. If you're using some kind of Active Directory system or domain controller, you're going to have that server set up and then have your computers configured to that. Usually that's common with Windows systems when you use them. All right, so that was workstations. As you know, the idea was pretty easy, right? Pretty straightforward. Really, these slides are just about the contrast so that we know the terminology. Servers are the next topic, as you can see here. And this still, we're talking about hardware, right? So we're not talking about software yet. And it's hardware that it really just relates to dedicated machines, right? So you can see their picture again. You have the essence of what a server is, right? So you use some kind of rack, right? The rack there, and then you have some excuse me, some servers there of all kinds of shapes and sizes, and they're all working together. And you have multiple computers there that can be accessed via the network. So maybe this is your web server, right? And then this is an email server, and then you have a DNS server and a multimedia server and all kinds of things, a database server. So they have basically a lot of specific tasks, and sometimes you want to have them separated out for what for your research or manufacturing. You have manufacturing systems that use them, or your payroll, etc. So it's basically the hardware. Okay, you can see here more examples. I just have some pictures of how you have to deal with them. This is an example of another rack, right? Might want to have it closed sometimes for security reasons, etc. So, so the question is, how are servers different than workstations? So, whereas workstations are really for one person or people one at a time, they log into a computer. A server is really meant to be accessed either in the intranet for the organization or via the internet, etc. But it's a network device meant to provide services to multiple people at the same time, kind of in parallel, serve many people. Okay. So they're different from desktops. The formal. These are the formal characteristics that differentiate a server from a workstation. So they're different from desktops. Many may serve tens, hundreds, or many thousands of users, right? So that's the idea. They require to have high reliability, right? Because if it's your e-commerce site or your multimedia site or your GitHub site or your Brightspace, right? You really need when if you have your homework and you've been working on it for a long time and you're done and you want to submit and then the system goes down, that's you want to be done, right? So you can't submit and then you're kind of just waiting there. So that's kind of a bad thing. So reliability is pretty important. That's translated into this idea of uptime. Now you already, in the first lab assignment that we did, you already explored uptime, right? So I gave you the Linux command that if you type that up, it gives you uptime. And that was your first monitoring action or example that we've covered in this class. As you know, one of the big things of the course is the idea of monitoring your systems and automation. As we move forward later in the semester, we're going to look at traditional protocols like a Simple Network Management Protocol, or SNMP, that give us a lot of information about a system. And we'll talk about that, you know, how that can work theoretically, but uptime really, you know, for a single machine is just how long it's been on, right? And so we can take, you know, you already know how to get that information, and that's just pretty important. They require tighter security, right? Given that multiple people might be accessing these computers and they might have important information, you know, if it's an e-commerce site, you know, it might take credit card information or might store sensitive information. So they require higher security. They're often, you know, a bigger investment, right? And that's why a lot of people nowadays just move to the cloud, right? So that it's expensive to operate, to support, you know, to secure. You know, security actually makes it so much of a problem that they might just go with somebody that has a cloud service that really has the funds to provide all of these features. So they're expected to last longer because of the investment, though. So there might be a little bit more robust, or they might have a little bit more duplication, redundancy of, you know, hardware, basically, components. And it's the kind of device that you can actually amortize over time and across users. So, you know, depending on the investment, right, you know, it could be something that you can consider and even amortize, you know, like depreciate. All right, so different OS configurations and desktops. And in particular, they want to be deployed in a controlled environment, which is usually referred to as the data center, right? So that's, you know, kind of this idea that you have a data center that provides a lot of the features. You know, a room provides a lot of cooling, right? Because it's going to get hot in there with all that equipment. And so you need to have, you know, protect for surge protection, and need to have enough power to run all these machines. So there's a lot of considerations, and it's a controlled environment. It's secured, obviously, only by the sysadmin personnel. And then you saw those pictures of the rack, so the layout is also different. You might also need to establish, because you have, depending on the amount of computers, imagine somebody like Google who has millions of computers, right? Servers across the world. You know, they even need to have maintenance contracts with companies that can come in and fix the equipment. And then that takes you into services that are important, such as backups. We'll talk about how to do backups later on in the Linux commands and everything. And then better remote access. So we'll talk about services for remote accessing like SSH and so on later on. But that's, you know, servers typically are you know, will be different in these ways to workstations. So I already talked about rack mounting. This just mentions, you know, the space utilization issue, basically, right? And it provides a lot of the things that they might need to deal with the equipment. The hardware, you know, I'm not going to get into the hardware because obviously this hardware is constantly changing, but the specifications basically might need to be a little bit more reliable and powerful. And you know, so the question is, do they really cost more? Well, that just depends. If you run an efficient business, you really would measure things in terms of price versus performance, right? So it's really about quantifying, yeah, it might be a bigger investment, but that server will last longer and it's more efficient. So it translates into, you know, savings, et cetera. So it really, the way to measure it is not by looking at the cost initially, the offset, but just the onset, but just looking at the ratio there, measuring the ratio of price to performance. So everything else, you know, what I said, so maintenance contracts are important. We'll talk about scheduling tasks and data backups. So certainly this will be a very important topic. It relates to cron tabs. So we'll talk about that. So there's, they're unique with critical data. So we have to figure out ways of automating the process of creating backups and how to manage them efficiently. So we'll see that in a future lecture. Again, just some of the things to consider in data centers: physical security, air conditioning. Also, this is actually a lot of money is spent just cooling the systems. There's the networking infrastructure, obviously connecting to the network, fire protection suppression sometimes, and then proper power, right? And that includes surge protection and so on. Having a generator, for instance. Right, so those are all aspects that have to be considered when you think about just the data center itself. So operating systems, pretty much the same. We're talking specifically about Unix. Red Hat is a very common Linux version for enterprise, so certainly it's something to be aware of. Okay. There's Windows servers also, although not part of our discussion in this course. Certainly a lot of the general things apply to them as well. And then, servers, because they don't really have a keyboard and a monitor associated with every server, right? They require more of a remote administration via SSH, remote desktop for some Windows machines, or other XRDP for Linux, which provides a type of a Windows environment. Team viewer, there's a lot of tools out there nowadays that can help you to kind of see, have a GUI remote session. But otherwise, SSH is pretty much the standard because it's encrypted and it provides a tunnel, secure tunnel, basically. And then, there's issues like not just backups, but also mirrored boot disks, etc., because drives may fail. So you want to have some kind of redundancy in your disks. And so there are some technologies for that as well, something called software RAID, right? And that's just nowadays, you can buy this software and hardware kind of from a vendor and just, the issue is configuring it correctly. Redundancy also applies to redundancy in the hardware itself with power supplies, for instance, where if one power supply fails, maybe there's a second one that allows the device to continue. So you can see that there, for instance, in this picture, right? Some kind of a switch in the network, and it's got basically dual power supplies. So if one fails, the other one can keep going. Now, what we will see later on when we look at SNMP and SNMP services is that those services will actually say, okay, one power supply went out, and they'll send out a message back to the NOC. The NOC is the Network Operations Center, some kind of an office where you monitor all your equipment. We'll talk about this later, but notifying that something just happened. Okay, so these are all issues that you kind of have to worry about. Nowadays, though, the software is so sophisticated that a lot of this is pretty straightforward to configure. But this, we're still talking a little bit about hardware here. And so you can see there the two power supplies. Hot swapping components, that's another term out there. Redundant components should be hot swappable. That just means that new components can be added without downtime. One fails, you can just kind of pull it out and pull in a new one. It might be a little bit more costly, right, to have something like that, but it's a trade-off between the downtime, right? So if you have critical systems that should not be down, Brightspace, for instance, right? You guys, especially nowadays, or Zoom or whatever, is definitely worth considering. Everything really in system administration is kind of a trade-off, right? So you can always get that computer that's really great, but you kind of have to do an assessment of the cost value of it. All right. I think that's it as hard. And then the alternatives nowadays, obviously, to expensive servers is basically just to, the cloud, right? So everything it tends to the cloud more and more. So that's probably everything will be in the cloud in the future. Here are just some examples of hardware. They're just kind of for fun. You don't really have to take a look at them. Blade servers, the terminology blade servers just means those servers that you can slide into the rack. They kind of look like this, right? They're very long, skinny, and then they go into the blade chassis. They go and slide in and out. Okay. And then the performance metrics, as we talked about, you measure latency and throughput, and you also look at uptime in particular. So we're not really going to get into the specifics of that, obviously, just in a sense to be aware that we want to measure some metrics at some point, and we'll look at some of the tools that it will allow us to do something like that. All right, and now that we've talked about workstations, and servers, which is kind of the hardware, then we're ready to look at the next topic, which is services, right? And when we talk about services, we basically mean now the software, right? So we talk about, whereas before we were talking about hardware, now we are talking about the software that is running on the servers. And basically it's the software of the dedicated tasks that we want the system to perform. Also, before I forget, let me just do the course participation right now. I just remembered to do this, so give me a sec here. All right, so it's recording now. Just took the picture of your, I think it's due this Friday, so this is the last time. Okay, so we're ready to continue. So actually, the lecture today, although it's pretty simple and easy, at least so far, it's very important because it kind of lays out what we will be doing for the rest of the semester. What we will be doing for the rest of the semester is actually focusing on services. Now, there are many, many services, and we can't cover all of them in this course, but we will cover, obviously, some of the most important that provide us with specific principles about, what a server does, right? So the different, and this week, actually, on Wednesday, in the lab assignment, the handout that you guys have, you will start looking at the services, the services, the commands for them, and in particular, the concept that in Unix, services are usually associated with port numbers. So that's one of the, the first example actually, or question or problem in your lab this week is the fact that you will have services associated with port numbers. So we're talking about, remote desktop, or we're talking about SSH, for instance, right? So it's remotely accessing something. So SSH is associated with port 22, Telnet, another service. Telnet, another service is associated with port 23. Web, HTTP is associated with port 80, and so on, right? So that's the idea. We're going to look at some of those. These are TCP protocols, and then there's UDP and so on. So we will explore this idea in a little bit more detail on Wednesday in the lab. The lab will start with that. So now we can, formally kind of get into the idea of services. So basically, and you guys know this is pretty straightforward. You know that a server is hardware, whereas a service, if we want to define it formally, is the function that the server provides. Okay, so usually they'll say, oh, it's a web server, right? And it basically just means it's a regular server or a regular Linux server, but it just happens to be running Apache, and it's kind of dedicated just to Apache and nothing else. Right, so it's kind of dedicated to just Apache and nothing else. Okay. All right. So managing services. Services distinguish a structured computing environment from a bunch of standalone computers. That's really what it is. That's a fine definition. Larger groups are typically linked by shared services that ease communication and optimize resources. And then typically, typical environments have many services, right? So there's going to be your DNS, right? And 1 week we'll spend a lecture on DNS, and a lab on DNS should be very fun. There's going to be authentication services like, domain controllers, Active Directory, or radius servers, right? So in Linux, you have this idea of a radius server. Right? And this is usually for the network more so than, given that Linux machines are usually more, just servers, etc. It relates more to the network and the authentication of it. There's email services, printing services. So you hear the term, oh, the print server is down, because whenever you send something, a print from your laptop, your software laptop, you send it to that print server, then the print server might send it out to the physical hardware printers. So everything, it's pretty organized. There's other ones, syslog, servers, and so on. So that, there's many kinds of these. And I'm sure they can create more new ones, etc. A gaming server, multimedia server, repository servers, so on. So, key things with these services, remote access. There's also this idea that you have to get a license sometimes for some of these. Although with Windows, the great thing about it is, Linux is free and a lot of the services provided in Linux are exceptionally good, right? There's the DHCP server, software repositories, as I mentioned, the backup server, file server, and so on. So all of these are governed by some kind of a, when you hear the FTP server, right? Or they're governed by some program. It's just software. It's just code. Somebody wrote some code, right? And the code is running in the background. It's associated with a port number, and that's it. Okay, so that's the idea. So providing a service then means not just putting together the hardware and software, but it's about making the service available, reliable, scaling the service as needed, maybe adding more servers, etc. And then also, don't forget, monitoring, maintaining, and supporting the service. So there's also here, just like with the workstations where we had a life cycle, also here, there will be a life cycle. Okay, are there any questions so far, guys?
I don't think so.
Yeah, it's pretty easy stuff, pretty easy. Just laying out some of the ideas here, but this kind of illustrates a lot of the topics. Obviously, we can't cover all of these, but we'll cover, like I said, with monitoring, we'll cover SNMP and so on. So we'll cover different different protocols here and there as they relate to these individual services. And as you will see, I'll throw in scripting and also there will be some slides kind of like these, but specific for that particular scenario. But what's important about today's slides is that they, in particular the services one, is they give you an idea, right, of kind of, okay, these all of these things are a lot, and we will explore some of them, the ones that really convey something pretty important. You know, there's obviously security involved here, and you might have servers for instance, a what is called a proxy firewall, right? A proxy firewall. In Linux, you can have one. There's a generic one called Squid, and it's a firewall, right, for blocking traffic, you know, Facebook and things like that. You can block it. We'll see how to use that actually when you take 454. So some of these actually are distributed out even in other classes, given that to do a lab we would need, you know, more time. But we'll cover a lot of these. Anyway, so generically speaking, these are the services that we have and what they require. So how do you design a solid service? Obviously, you start with getting understanding what your customers require, right? When we say customers, from the point of view of system administration, as we will see in these slides, you will kind of see that the task of system administration is a service task. You're providing yourself a service to the other employees of your organization, right? And so that means that those can be your customers. So you need to understand what is it that they need, right? So we needed, for instance, in our program, we needed GPU boxes. We needed GPU boxes to be able to teach our data science courses, right? But the GPU boxes, we had some physically GPU boxes scattered all over our labs. We wanted to remotely access these GPU boxes. And so we were thinking about SSH, but then information services here at the university didn't really want to give us permission to use SSH services. And what about students when they want to do their homework from home? Okay, now they have to get a VPN into the school, then use that VPN to access the computers via SSH. It was just, you know, and really, because of security and everything, the university just had a policy that it really did not want to give us SSH, even from one of our labs to another lab. So if you remember, you guys, hopefully you still remember the labs, but, you know, from one lab to the other, right? And so we were the customer. We wanted it. We didn't care how we solved the problem. We just wanted to get our machines. As it turns out, we went to the cloud, right? So now we have, Purdue has this a cloud called Scholar, and there's a lot of servers up there. And so, you know, of course, any of our courses can be tied to one of these, and then we can use the resource. So we ended up getting the GPUs kind of in the cloud service there. But at the end of the day, we got exactly what we wanted. So that's really, you know, designing a solid service is about that. They were able to set up this service of providing Scholar, and Scholar just manages very efficiently many GPU boxes, right? Some kind of virtualized environment that they have there. And so that's basically what this is saying. So, you know, what is the reason? Define the service level agreement, you know, how much support do we get, you know, all of that, enumerate the services that you want, and then of course estimate the satisfaction of the user. So we are definitely pretty happy with the service that we got, and it was, you know, a cloud type of solution. So here's a funny slide. If you can hopefully understand what it's saying here. So it's about understanding what, you know, remember, it's, you know, it's not about coding necessarily, but it's about implementing a system. So here is, you know, how the customer explained it, right? So that's us. We wanted this, but then keep in mind that communication, especially with more complex systems, is not always understood, right? So then you have how the project leader understood it, how the analyst designed it, how I like this one, how the programmer wrote it, because it doesn't run. And then, which is typical of code, right? It just doesn't run. And then how the business consultant described it, right? So that this one's pretty comfortable because they're salesperson, basically a sofa on ropes there, how the project was documented. So this reminds you that you should document. Now, how many of you document your projects, right? So you can see there's nothing there. What operations were installed? Basically, they kind of did it, but there's barely a rope. And then, now here's how it was billed. This one I think is pretty funny, right? So it's super expensive. How it was supported, whenever they support it, they basically just chop it off. And then what the customer really needed, right? So they didn't really need this, they kind of needed this. So it's like what we were saying, you know, we wanted GPU boxes and everything was getting pretty complex about the GPU boxes. We really just needed some cloud service, which they provide. So this is a pretty funny slide, I think. All right, excuse me. So basically, you want to design a solid service. Communication is going to be pretty critical. Okay, getting the information and obviously the budget. We just got lucky in our case. It's not very expensive, so all right. And then here's a case. You can read through it. Pretty interesting. I've given you one example with the cloud service. So everything else, you can just read it. You know, it's a little bit more specific to an example. So take a quick look through it. It's just getting into examples of designing a solid service. So we'll talk about some of these things later on in the semester. You know, like monitoring. You see these graphs. So I'll show you guys how these graphs can be done automatically from. You'll see. You'll see how pretty interesting all of that is. But you can monitor a system, and every system has thousands of variables that you can actually query, right? And you can, you know, plot in graphs and everything, and just have a very good picture of your monitor. You can picture the network and your network traffic by geolocation. And so geolocation just means that we can see where the traffic is going. Is it going to countries that you don't even do business with? You know, does that mean that you've been hacked, or is there a virus Trojan that is sending information to Germany? You know, and you've never even gone to a German site. So what's going on? So we'll take a look at some of that monitoring later on. Some of the terminology, Damon, I'll describe some of these when I go into the Unix way, but these are just some of the terminology. All right, so that kind of concludes this set of slides, which, as you know, it's what I wanted to cover first. Give me a sec. I need to share this. All right, so that was one set of slides that just I wanted to cover the differences really between. I'm sorry. The differences between workstations and servers and services. So hopefully now you have a clearer picture of the terminology. Okay, and this kind of lays the motivation for everything else that we will do this semester as it relates to, you know, why we're going into all the different tasks, right? They're all part of, we're studying either a workstation or a server, Linux, and then now that we have the OS, the environment, and then within it, all the different services that it can provide, okay? So that, which are called, in Unix and other multitasking computer operating systems, they're called daemons, right? You can see the spelling there, D-A-E-M-O-N. And so they basically, services will be called daemons, and they're programs, basically. They're computer programs on your server. They run as a background process, okay? So they're not gonna be associated with a terminal. Instead, they just kind of run in the background. they're not under the direct control of any interactive user. They might have their own account. They have their own account, but they're not running in anything that you can see. And instead, they're associated usually with a process, and they're associated with a port number. Right? And typically daemon names end with the letter D. For example, syslog D, right? So we're going to learn about the syslog service later on when we talk a little bit about auditing and things like that, logging and keeping track of information. And then just be aware that the service that runs is called syslog. The same, you know, if you think about the SSH service, you know, also ends with a D. All right, so we'll take a look at these later on. When we look at grep and grep and awk, we'll probably grep some of these services just to kind of visualize them as they are running. But, you know, we'll be discussing basically a lot of daemons for the rest of the semester, a lot of services, you know, as they're also called. All right, so this is the conclusion of this particular set of slides. Now that we've covered workstation servers and services, you know, we are ready basically to talk about services in particular, right? And before we get into all the services, we kind of have to go over the Unix way, right? So we need to understand what is called the Unix way, which is the philosophy, if you will, of Linux, right? Of Unix in general and Linux in particular, as we are covering it this semester. So what I want to do for our discussion of the Unix way, which is kind of, you know, lead in before we talk about individual services, is I want to keep it as a separate video, just because this video is very much one thing, and then the Unix way is pretty much a different thing. Okay, so what I'm going to do right now, the only way that I know how to do this, is I'm going to exit out of this session so I can generate the video, and then I will immediately get back on again. So I need to let you guys back in, and then we'll create a second video for today. So there will be two videos. The other one will just be titled The Unix Way. Okay, that way it'll be easier to separate the two things. Does that make sense, guys?
Sounds good.
Yeah, that makes sense. Just join back,
Yeah,
right?
that works.
Yeah, that way I'll have two videos and they're perfectly separated out. So I'm going to then proceed to do that. So that'll take just under a minute. Okay, so I'm gonna exit out of here and then I'll be back. Okay. All right, see you in a sec.